Medical science has reached a point where a simple prescription can clear the human body of severe metabolic risks. We now have the chemical tools to drive circulating bad cholesterol down to near zero and actively dissolve visceral fat from our organs. A new class of highly effective cardiometabolic medications, specifically GLP-1 agonists and PCSK9 inhibitors, has given doctors unprecedented control over our internal chemistry, which presents a very modern paradox. But starting at age 40, he receives aggressive, state-of-the-art preventative medications to manage his blood pressure, blood sugar, and cholesterol. Twin B takes the exact opposite approach. He maintains a rigorous, elite athletic lifestyle, training 10 hours a week, and eats a strict whole-food, plant-based diet. He refuses all preventative cardiometabolic medications. Twin C tests the absolute biological limit. He lives the exact same elite athletic lifestyle as Twin B, but carefully layers Twin A's aggressive pharmacological drugs on top of it. Holding genetics perfectly equal and tracking them from 30 to 70, this model isolates the biological difference between chemical management and physical behavior. Fast forward 40 years. At age 70, Twin A's medical chart looks entirely flawless. His cholesterol is incredibly low, and his blood pressure rests right at the optimal target. The GLP-1 medications suppressed his appetite and cleared dangerous fat from around his liver, all without him ever needing to step foot in a gym. But that pharmacological weight loss hid a severe cost. Because he remained sedentary, his body catabolized functional muscle tissue for energy alongside fat. He has developed sarcopenic obesity. His basal metabolic rate has crashed, and his weakened skeletal frame leaves him highly vulnerable to a fatal fall. More critically, his cardiorespiratory fitness, his VO2 max, has plummeted. No drug on Earth can stimulate mitochondrial biogenesis or expand capillary density. At age 70, Twin A's physical engine is so degraded that he is dangerously close to losing his ability to live independently. Twin A reveals a massive blind spot in modern medicine. A perfectly normal lab panel is an illusion if it masks structural fragility. The drugs controlled his chemicals, but they completely failed to build physiological reserve. Twins B and C tell a different physical story. Decades of high-volume aerobic and resistance training forced their bodies to adapt. Their hearts pump massive stroke volumes, and their muscles are dense with highly efficient mitochondria, creating a biological buffer against infection, trauma, and aging. But Twin B, the unmedicated athlete, has a hidden flaw inside his system. Even with a pristine plant-based diet, his liver naturally produces a steady stream of atherogenic particles, known as ApoB. It happens slowly, but over 4 decades of exposure, those ApoB particles inevitably become trapped in his arterial walls. Despite his perfect physical discipline, he has still seeded a subclinical layer of plaque in his heart. Twin C solves this biological constraint entirely. By taking targeted lipid-lowering drugs, like a PCSK9 inhibitor, starting in early adulthood, he crushes his ApoB levels to the absolute physiological floor. By minimizing those circulating particles, Twin C removes the physical substrate needed for plaque to form in the first place. Exercise builds an invincible engine, but only targeted pharmacology can clear the microscopic debris that accumulates in the fuel lines over decades. To see exactly how these interventions interact, we can introduce a curveball. Look at this chart. These 3 bars represent the baseline levels of atherogenic ApoB particles. What happens if all 3 twins abandon their clean diets and start eating a high-saturated fat paleo diet? For Twin A and Twin C, the lines barely move. Their lipid-lowering medications act on the exact same hepatic clearance pathways that dietary saturated fat disrupts. The drugs simply block the penalty. But Twin B's cholesterol spikes aggressively. In lean, insulin-sensitive individuals, a high-fat diet can trigger the lean mass hyperresponder phenotype, where the body floods the bloodstream with transport particles to move fat for fuel. Without a drug buffer, his ApoB levels soar into a high-risk zone. We can map the ultimate fate of all 3 men using a Gompert survival model. This first curve tracks the average American male. He lives to about age 77, but he spends the last 12 years of that life suffering from chronic disease, a massive period of morbidity. Here is Twin A. His aggressive medications successfully suppress a fatal heart attack, buying him an extra 3 years of life. But his physical frailty leaves him with a 9-year tale of illness and dependency. Twin B's trajectory reveals the power of physical fitness. His survival curve shifts to the right, cresting at age 89, and that long shadow of end-of-life sickness shrinks down to just 4 years. And finally, Twin C pushes the human biological limit. By combining the cardiovascular engine of an elite athlete with the plaque-clearing precision of modern drugs, he reaches a median lifespan of 91. The ultimate goal demonstrated here is the compression of morbidity. Success isn't simply delaying the date of your death, it is remaining a fully functional, highly capable human being right up until the very end. The 40-year triplets experiment shows the clear biological hierarchy between medical management and physical behavior. A normal lab panel and a healthy body weight will not save you if your heart, lungs, and muscles lack the structural capacity to handle the acute stressors of aging. That physiological reserve has to be actively earned through sweat and physical strain. Modern medications are miraculous tools, but they are designed to be a precise, protective supplement layered over a hard-earned physical foundation. They are not and never will be a substitute for the effort required to build it.